Welcome to our very first deep dive here on the Girl Has It All channel.
Woo!
We're going to be kicking things off with something pretty amazing.
Okay.
Quantum physics. You might be thinking, quantum physics, isn't that like super complicated?
It can be, yep.
Yeah, it can be, but it's also incredibly cool, and believe it or not, it's already impacting our everyday lives in ways you might not even realize.
Definitely.
So joining me today is Jenna, our resident quantum expert. She's here to break down some of the biggest quantum breakthroughs of 2024 and help us understand what they mean for, well, all of us.
I'm so excited to be here, Thomas. And yeah, what's fascinating is how these quantum advancements, they aren't just happening in labs anymore. They're already making waves in fields like finance technology, even our understanding of the universe.
So cool. Let's dive in. First up, quantum computers.
Okay.
We've all heard the hype, but are they actually a thing now, or is this still sci-fi territory?
They're definitely a thing. And they're moving way beyond just theory. Companies like IBM already have over 250 clients using their quantum services. Yeah.
Wow, so this isn't just a few scientists tinkering in a lab anymore.
Not at all. We're seeing what we call the emergence of quantum software. So think of it as a whole new way of writing code. That takes advantage of the unique properties of quantum computers.
Right.
These algorithms can tackle certain types of problems way more efficiently than traditional methods.
Okay, so you're saying quantum software is different from the software on our laptops and phones.
Exactly.
Can you give us a real-world example of how this is being used right now?
Absolutely. One area where it's making a huge impact is weather forecasting. Quantum algorithms can analyze massive amounts of weather data and produce much more accurate predictions.
So instead of just seeing a little rain cloud icon on my weather app, I can know exactly when that rain is going to start.
Yes.
Like down to the minute.
That's the idea. It's about taking forecasting to a whole new level of precision. And it's not just weather. Companies like Terra Quantum are using quantum computing for financial modeling, which can make financial processes much more efficient and potentially save a lot of money.
Speaking of advancements, I read about Google's new quantum chip called Willow.
Yeah.
That sounds pretty impressive. What makes it so special?
It's a big deal because it's a significant leap forward in quantum computing hardware. It's much more powerful and stable than previous chips, and it sparked a massive wave of investment in quantum computing.
Oh, wow.
This means we can expect even faster progress in the near future.
That's exciting.
Okay.
Let's get a little weird now. Are you ready to talk about quantum entanglement?
Always. It's one of the most mind-boggling concepts in quantum physics. Imagine two particles, no matter how far apart they are, linked in a way that defies our everyday understanding of physics. If you change the state of one particle, the other instantly changes its state as well.
Instantly. Even if they're miles apart.
Yes.
That sounds like something out of a science fiction movie.
It does, doesn't it? That's why Einstein called it spooky action at a distance. It seems to violate the laws of physics as we know them, because it suggests that information can travel faster than the speed of light.
Okay, my mind is officially blown. So what's new in the world of entanglement this year? Have there been any major discoveries?
Researchers at the Large Hadron Collider observed entanglement between top and anti-top quarks. What's amazing about this is that it's the highest energy observation of entanglement ever recorded. It's pushing the boundaries of what we know about the universe.
So what are the implications of this discovery? What does it mean for us in the grand scheme of things?
That's the big question. Physicists are still trying to figure that out. Some believe entanglement could revolutionize communication. Imagine sending messages instantly across vast distances. Others think it could hold the key to understanding consciousness and the interconnectedness of everything in the universe.
Oh, that's getting pretty deep. But it's what makes quantum physics so fascinating. It challenges our fundamental understanding of reality.
Exactly. It forces us to question everything we thought we knew about how the world works. And speaking of challenging our understanding, there's another breakthrough I want to tell you about. Scientists have actually measured the shape of electrons at the quantum level.
Wait, they can actually see the shape of an electron? I thought those were way too small to observe directly.
Not with our eyes, of course. They used incredibly sophisticated instruments and techniques to probe the quantum world and measure the geometry of electrons within solids. Think of it like taking a 3D scan of an electron's energy field.
Okay, I can kind of picture that. But why is measuring the shape of an electron such a big deal?
Because it revolutionizes our understanding of materials at their most fundamental level. It helps us understand how electrons determine a material's properties, like its strength conductivity or even its ability to interact with light. And this knowledge could lead to the development of entirely new quantum materials and technologies.
New materials, huh? Like what kind of things are we talking about?
We're talking about materials with unprecedented strength, flexibility, and conductivity. Imagine super efficient solar panels, ultra-fast computer chips, or even materials that can manipulate light in ways we never thought possible. The possibilities are practically endless.
This all sounds pretty incredible. But with all this amazing quantum progress, are there any potential downsides? I mean, there's always a flip side to every coin, right?
That's a great question, and it brings us to the topic of quantum security threats. As quantum computers become more powerful, they could potentially crack the encryption methods we currently rely on to secure our data.
Wait, so all our online transactions, financial systems, even government secrets could be vulnerable to hackers with access to quantum computers.
That's the concern. While a quantum device powerful enough to break current encryption might still be a few years away, it's a threat that cybersecurity experts are taking very seriously.
So it's like a high-stakes race between quantum code breakers and code makers.
Exactly, and the stakes couldn't be higher. We're talking about the security of our entire digital world.
This is heavy stuff. We've covered so much ground already, from super-fast computers and spooky connections to new materials and potential security threats. And this is just the beginning of our quantum journey.
It really is an exciting time to be following quantum physics. It seems like every day brings new discoveries and possibilities.
Before we move on to our next topic, let's take a moment to recap what we've learned so far. We started by talking about quantum computers and how they're moving from theory into reality with real-world applications. Then, we delved into the mind-bending concept of quantum entanglement and explored its potential implications for everything from communication to consciousness. And finally, we touched on the groundbreaking ability to measure the shape of electrons, which could revolutionize material science.
It's incredible to think about how these seemingly abstract concepts are already shaping our world in profound ways, and this is just the tip of the iceberg. As we continue to unravel the mysteries of quantum physics, who knows what other amazing applications and implications we'll uncover.
Well, I don't know about you, Jenna, but I'm definitely ready to dive deeper. When we come back, we'll continue our exploration of quantum physics and its impact on everyday life. So stay tuned, folks, because we're just getting started.
I can't wait, Thomas. This is where it gets really interesting.
And that's a wrap on part 1 of our quantum deep dive here on the Girl Has It All channel. We'll be back soon to continue our exploration, so be sure to hit that subscribe button so you don't miss out.
Until next time, keep those quantum minds curious. Welcome back to our deep dive into quantum physics. Before we went to recap, we were discussing the potential risks of quantum computing, particularly in cybersecurity. It's a bit unsettling to think about how this incredible technology could also be used for malicious purposes.
Yeah, it definitely raises some concerns. I mean, we rely so heavily on digital systems for everything these days. It's a bit unnerving to think that our data might not be as secure as we thought.
It's important to acknowledge those risks, but it's not all doom and gloom. The good news is that experts are already hard at work developing quantum-resistant encryption methods.
So there's hope. We're not all going to be victims of quantum hackers.
Absolutely not. The cybersecurity community is well aware of this potential threat, and they're actively researching and developing new encryption algorithms that can withstand the power of quantum computers.
That's reassuring. It sounds like there's a real intellectual arms race going on in the cybersecurity world.
You could say that. It's a fascinating field, and it's attracting some of the brightest minds in computer science and mathematics. They're essentially trying to stay one step ahead of the quantum code breakers.
I imagine it's like a constant game of cat and mouse, with both sides pushing the boundaries of what's possible.
Exactly. And the stakes are incredibly high. We're talking about the security of our entire digital infrastructure, everything from online banking to national defense.
Speaking of high stakes, let's shift gears for a moment and talk about another area where quantum physics is making a big impact: medicine. I read that there are some promising developments in quantum sensing for medical diagnostics. Can you tell us more about that?
Absolutely. Quantum sensing takes advantage of the extreme sensitivity of quantum systems to detect and measure things with incredible precision. In medicine, this could revolutionize how we diagnose and treat diseases.
So how does it work? What kind of things can quantum sensors detect?
They can detect incredibly subtle changes in magnetic fields, gravity, and even temperature. Imagine being able to detect cancer cells in their earliest stages, long before traditional methods could pick them up. or monitoring brain activity with unprecedented detail to better understand neurological disorders.
That's incredible. It sounds like quantum sensing could lead to earlier diagnoses, more personalized treatments, and potentially even cures for diseases that are currently incurable.
It has the potential to be a game changer in medicine, and we're already seeing some exciting developments in this area. For example, researchers are developing quantum sensors that can detect tiny changes in the magnetic fields produced by our hearts and brains, providing much more detailed information than traditional EKGs and EGs.
It sounds like we're on the cusp of a new era in healthcare, where quantum technology plays a central role in diagnosing, monitoring, and treating a wide range of conditions.
I believe so.
Hmm.
And it's not just limited to diagnostics. Quantum technologies are also being explored for drug discovery and development, gene editing, and even personalized medicine tailored to an individual's unique genetic makeup.
Wow. It's hard to wrap my head around all the potential applications of quantum physics in medicine. It feels like we're just scratching the surface of what's possible.
We are, and that's what makes this field so exciting. Every new discovery opens up a world of possibilities and challenges our understanding of what's achievable.
It's inspiring to think about how these advancements could improve the lives of millions, if not billions, of people around the world.
Absolutely. And it highlights the importance of continuing to invest in quantum research and development. The potential benefits for humanity are immense.
Okay, so we've talked about quantum computers, entanglement, new materials, cybersecurity threats, and even the incredible possibilities of quantum technology in medicine. Is there anything else on the horizon that you're particularly excited about? Any other mind-blowing breakthroughs we should be aware of?
One area that's generating a lot of buzz is quantum communication. It leverages quantum phenomena like entanglement to create ultra-secure communication channels that are virtually unhackable. It could revolutionize how we share sensitive information, from financial transactions to government secrets.
Unhackable communication. That sounds pretty amazing, especially given all the concerns we have about cybersecurity these days. How does it work?
It relies on the principle that any attempt to eavesdrop on a quantum communication channel would inevitably disturb the quantum state of the particles being used to transmit the information. This disturbance would be immediately detectable, alerting the sender and receiver that someone is trying to intercept the message.
So it's like having a built-in alarm system that goes off if anyone tries to peek at your message. That's brilliant.
It is. And because it relies on the fundamental laws of physics, it's theoretically impossible to break. It's the ultimate form of secure communication.
It sounds like science fiction, but it's actually happening right now.
It is, and it's moving from the realm of theoretical research to practical applications. Several countries are already investing heavily in developing quantum communication networks, and some companies are even offering commercial quantum key distribution services.
This is incredible. It feels like we're living in a time of unprecedented scientific and technological advancement. Quantum physics is no longer just a theoretical concept confined to textbooks and laboratories. It's shaping our world in profound ways. And it's only going to become more influential in the years to come.
I couldn't agree more. And the most exciting part is that we're just at the beginning of this quantum revolution. Who knows what other amazing discoveries and applications await us?
This has been an incredible journey so far. You've opened our eyes to a world we barely knew existed. And you've done it in a way that's both informative and engaging. I'm eager to hear what else you have in store for us in the final part of our deep dive.
I'm glad you're enjoying it. And trust me, we've saved some of the most mind-boggling stuff for last.
Well, on that note, we're going to take a short break. But don't go anywhere, folks, because we'll be right back with the thrilling conclusion of our quantum adventure here on the Girl Has It All channel.
Stay tuned.
Welcome back to the Girl Has It All channel. We're wrapping up our very first deep dive, and what a journey it's been. We've gone from quantum computers to entanglement, from new materials to unhackable communication. It's incredible how this field is pushing the boundaries of science and technology.
It really is a fascinating time to be alive, and witnessing this quantum revolution unfold, it's like we're on the verge of a whole new era of understanding and innovation.
You know, one thing that keeps coming back to me is this idea of interconnectedness that you mentioned earlier, especially in relation to quantum entanglement. It's such a profound concept. Does this mean that everything in the universe is somehow linked at a fundamental level?
That's a question that has captivated physicists and philosophers for centuries. And while we don't have all the answers yet, quantum entanglement does seem to suggest that there's a deeper level of connection between things than we previously imagined.
It's almost like we're part of some grand cosmic web woven together by these invisible quantum threads.
That's a beautiful way to put it. And it makes you wonder about the implications for our understanding of consciousness, the nature of reality, and perhaps even the origins of the universe itself.
It's mind-blowing to think about. But before we get too lost in the philosophical implications, I want to bring us back to the practical side of things. We've talked about a lot of exciting possibilities, but what are some of the challenges that still need to be overcome before quantum technology becomes truly mainstream?
One of the biggest challenges is scalability. Building and maintaining large-scale quantum computers is incredibly complex and expensive. These systems are extremely sensitive to their environment and require specialized equipment and expertise to operate.
So it's not like we'll all be carrying around quantum computers in our pockets anytime soon.
Probably not in the near future, but that doesn't mean progress isn't being made. Researchers are constantly working on new approaches to quantum computing that are more scalable and cost-effective.
That makes sense. And what about the ethical considerations surrounding quantum technology? There's always a potential for misuse with any powerful new technology.
You're absolutely right. It's crucial that we develop and deploy quantum technology responsibly and ethically. That means having open discussions about the potential risks and benefits, establishing clear guidelines for its use, and ensuring that these advancements benefit all of humanity, not just a select few.
I agree. It's important to consider the broader societal implications of these technologies and make sure they're used for good, not for harm.
Exactly. We need to be mindful of potential biases that could be built into quantum algorithms, and ensure that these technologies are used to promote fairness, equality, and justice.
It sounds like there's a lot to consider as we enter this new quantum era. It's both exciting and a bit daunting.
It is, but I believe that by approaching these challenges with the spirit of collaboration, open-mindedness, and a commitment to ethical principles, we can harness the incredible power of quantum physics to create a better future for everyone.
Well said. As we wrap up our deep dive into quantum physics in daily life, I want to thank you for being such an insightful and engaging guide. You've demystified a complex subject and given us a glimpse into a world of possibilities that most of us never even knew existed.
It's been my pleasure. I always enjoy sharing my passion for quantum physics and exploring its potential to transform our world.
And to our listeners, thank you for joining us on this incredible journey. We hope you've enjoyed this deep dive and that it sparked your curiosity about the wonders of quantum physics. Remember, the world is full of mysteries waiting to be uncovered, and quantum physics is just one key to unlocking them. So stay curious, keep exploring, and never stop asking questions.
That's the spirit. And who knows, maybe one day you'll be the one making the next groundbreaking discovery in quantum physics. Until then, keep exploring the quantum world, and we'll catch you on our next deep dive here on the Girl Has It All channel.